Hi, I'm Tom with a list of interesting things. Today on the list of interesting scientific things is one of the most exciting things to discuss in recent memory. Not because of political squabbles this time or impending danger, but because of the joy and the hope it brings to all of us humans. The Perseverance Rover. On July 30th, 2020, in the midst of the greatest pandemic in living memory and in the throes of one of the spiciest elections in the history of America, NASA was still hard at work, working on this launch. More than a decade of hard work by the cleverest Americans in the history of the country culminated in that launch on that day. Perseverance was thrown to the heavens on an intercept course with our little red neighbor. And as I speak these words, it's traveling at a blistering 47,000 miles an hour en route to its destination. And tomorrow, February 18th, 2020, a little bit before 4 p.m. Eastern Standard Time, that little chunk of Earth rock will land. That conglomeration of steel and silicone, held together with nothing but rivets and hope and a NASA patch, will touch down on Mars. There's so much I want to talk about. So much I want to rave about and get excited about. But this video is only so long, and I'm not an engineer, and I don't work at NASA. I'm just some idiot on the internet. Everything you see will be an overview, framed through the lens of an amateur's eyes. For more detailed information, please check out the links in the description. Always check out experts. Don't trust me, just get excited with me. And as always, I hope to subscribe to stay up to date on all the most interesting things. Let's dive in. First, the descent. We're going to check out this from News 4 NBC Los Angeles, where they go step by step through the landing process. First, tomorrow, February 18th, 2020, at exactly 12:38 p.m., the cruise stage separation happens and the landing officially begins. This is when the last part of the spacecraft proper, with the part that allowed the NASA team to do little finite bits of re-engineering and little bits of steering, little bits of course correction. That is the time when this will break off and fly away. Then it will just be the capsule, just the part that hurtles into the atmosphere. Then, at 12:48, atmospheric entry begins. At speeds of upwards of 12,000 miles an hour, it will hit the top layer of the Martian atmosphere and it will begin what is colloquially referred to as the 7 minutes of terror. That's because between the times of 12:48 p.m. and 12:55 p.m., the rover will go from 13,000 miles an hour to a nice, brisk walking pace of 1 mile an hour. Then it will land. Peak heating occurs at 12:49 p.m. All that's happening takes place over the course of minutes, seconds even. It will start to heat up, and it will warm to 2,300 degrees. This is where most of the slowdown will come from. This is, in effect, air braking. The heat shield on the front absorbs most of the heat as it slows down incredibly fast. At 12:52, the parachute will deploy. After it's lost most of its speed, where it's going, I believe, at about 700 miles an hour, dropped down from 13,000 a few minutes before, it will let loose its parachute. Then the heat shield pops off 20 seconds later. Then, my favorite part, as it slows down, the rover itself will detach from the top and it will be lowered to the ground 21 feet by a sky crane that will hover like a Jetsons spacecraft above the surface of Mars and will lower it down to the ground. At 12:54, the back shell will separate. That's the jetpack system. And then at 12:55 Pacific Standard Time, 3:55 Eastern Standard Time, touchdown will happen. And everyone at NASA will cheer. Now, that being said, the time delay between Mars and Earth is 12 minutes. It takes 12, the speed of light, the light distance between here and Mars is 12 minutes. That means it takes 12 minutes to get a signal from Mars to Earth. And that means that when we finally know what happened, it'll have been over for 12 minutes. When we see the first images of these 7 minutes of hell starting, it will already have been over for 5 minutes, for the better or the worse. So, that is hopefully how it will land. That's hopefully how it will arrive. But then what? Why are we going there at all? Well, there's literally dozens of experiments on Perseverance. Hundreds of things it'll do over the course of its lifespan. I'll leave links to the full list, but I want to go over a few of my favorites, starting with the biggest and most interesting, the search for life. Now, neither I nor anyone at NASA expects Labradors to bound up through the Martian sand and start licking the cameras, though I can't imagine anyone would complain about that. As near as we can tell, Mars is pretty much dead, but that doesn't mean it always was. Perseverance's landing site wasn't chosen by accident. It's a place called Jerizo Crater, and 3.5 billion years ago, it was a lake. That's right, a lake. You can even see the remnants of an ancient, long-dried riverbed that fed into it. We think it was in ancient, nutrient-rich freshwater pools that life first evolved here on Earth. Perseverance will let us see, using a number of tools, if the same thing happened on Earth. I should say, if the same thing happened on Mars as did on Earth. These tools will include the scanning habitable environments with Raman and luminescence for organic and chemicals. That's a wonderfully long name that happens to spell out the codename Sherlock. Sherlock will scan the soil beneath Perseverance to look for signs of microbial life. This is, of course, in addition to simple visual techniques employed by the rover's camera setups. Who knows? Maybe, just maybe, we'll find seashells in the Martian lake bed, or something similar. Up next, we have the Mars Oxygen In Situ Resource Utilization Experiment, codename MOXIE. Gotta love how they stretch for those acronyms. This is a small proof of concept. It's designed to, simply put, turn the carbon dioxide in the thin Martian atmosphere into oxygen. This is spectacularly important for obvious reasons. First and foremost, I, being a human, would rather like to visit Mars, and I, being a human, would rather like to breathe, so I find oxygen very useful. Furthermore, oxygen is one of the main ingredients in one of the most cost-effective propulsion methods. If explorers want to go to Mars, currently they would need to bring their own fuel to get there and bring their own fuel to get back. If fuel for the return journey could be synthesized on site, it would reduce costs immensely and make manned Mars missions much more viable. Now brace yourselves for this one. There's going to be a helicopter on Mars. I'm going to say that again. There's going to be a helicopter on Mars. Now, it's not a big one. It's barely the size of a common drone you find here on Earth, and it's not much more than a flying camera. But it has to be that small because of how thin the Martian atmosphere is. But it is an incredible and daring new leap. It's called Ingenuity, and it will be the first thing ever flown on Mars. Because the atmosphere is 99% less dense than it is here, the rotors need to beat much, much faster, and the helicopter needs to be much lighter. But in spite of those engineering challenges, it was made and it's on its way. This proof of concept could pave the way for a whole suite of aerial exploration techniques in the future. It also means that we here on Earth will get some really cool aerial footage on Mars. And it also means that in the next few days or weeks, someone will get the prestigious title of being the first person to fly something on another planet. Finally, I want to talk about something a little simpler. I never, in 1,000 years, would have thought to put something as simple as a microphone on the rover. It never would have occurred to me that there would be anything to hear, but now that I've thought about it, there's nothing I want more. I'm not talking about aliens whispering behind the camera. I'm talking about normal sounds. The Martian sand streaming across the landscape and contacting the rover. The Mars wheels turning and crunching. The winds of another world whipping through your ears, as close and as audible as a breeze blowing across a plain or a desert, anywhere here on Earth. It's the same thing with the cameras. Yes, there will be cameras. Obviously, there will be cameras. But that's not what I'm talking about. Set into the rover's head, about 6 feet off the ground and a few inches apart, are two little cameras called collectively Mastcam Z. Just normal cameras. They're kind of fancy. They have really good optical capabilities, but in essence, they're just normal cameras. They give the images of whatever the rover is experiencing at the height of a standing adult. That means if you have a pair of VR goggles, which are cheap and getting cheaper, you can load in the images of Mars. And you can look around as though you were standing there. You can put your headphones on and listen to the wind whip past your ears and see the dust blowing across the iron dunes as if you were standing there. What a way. I cannot think of a better way to inspire the people of Earth than to let them see through eyes and listen through ears currently standing in Martian soil. Which brings us to one final question. What does that mean for us here on Earth? In addition to the joy and inspiration that this brings to a young new generation of nerds, this is also the herald of a new generation of space exploration. Currently, NASA wants to have boots back on the moon in 2024. Organizations like Virgin Galactic, SpaceX, Blue Origin, and countless others are approaching passenger space travel not as science fiction, but as a real goal in the next few years. Perseverance will be searching for life on our frosty little cousin of a planet, and if we find it long since fossilized or wriggling in the Martian tundra, that will be a profound day for the human race. We might know, finally, that our little blue ball is not alone in harboring life. But even if it doesn't find life, that's no cause to despair. If there's one thing you take away from this beautiful event, let it be this: that this is a testament to what we can do, to how far we can go when we work together and explore something beautiful. And I mean that very literally, because I don't think real human exploring is too far away. I'll leave you with a quote from Phil Plait, one of my favorite nerdy astronomers, as if there was any other kind. Quote, "Eventually, there will be life on Mars. And it'll be us. Until then, be like the Perseverance Rover. Be ambitious, courageous, meticulous, and far-reaching. Be bold, be confident, and bring with you, wherever you go, the hopes of all those who came before, and all those still to come, whether you be on a little blue dot or a little red one. And above all, be interesting." I'll see you next time.